Yesterday, we have seen flash drum and its degrees of freedom. Now, let us see how to select the manipulated variables and its corresponding output variables. How to select output variables and its corresponding manipulated variables that we'll see today. The flash drum, in that we have seen that the total number of variables is 2n plus 7. That is total number of variables. Out of which 2n plus 3 equations we had. 2n plus 3 equations we had. Therefore, the difference between the two is 4. Therefore, degrees of freedom equal to, that is f equal to, degrees of freedom equal to 4. Therefore, only 4 variables we can control. That we have seen yesterday. These 4 variables are in a flash drum. This is the flash drum in which the pressure, temperature, feed flow rate, and H are the controlled variables we have seen, because pressure and temperature are important for quality. That's why we have to maintain pressure and temperature. Feed flow rate is important because to get the quantity, required quantity, feed flow rate has to be controlled. For safety aspect, we have to control the level of this flash drum. That's why these 4 variables has to be controlled, that we have seen. The 4 variables are feed flow rate, liquid vapor, pressure, temperature, and level. These are the 4 variables has to be controlled. We have seen manipulated variables. What are the manipulated variables available that we have seen? The manipulated variables are feed flow rate, liquid flow rate, vapor flow rate, and steam flow rate. These are the 4 manipulated variables. These are the 4 manipulated variables available. Process variables are 4. The problem here is, suppose this is M1, this is M2, M3, M4. Here this is PV1, PV2, PV3, and PV4. To control feed flow rate, which one of these 4 variables has to be used? We have to check, because all the 4 has an effect on FF. For example, like flow process, FF can be used to control FF. We can measure the flow rate. We can control the feed flow rate. That is one thing. If we adjusting that liquid flow rate also, we can control the feed flow rate, because if you adjust the liquid flow rate, the level will decrease or increase based on that downstream pressure will change. We can control FF. Similarly, vapor flow rate. If we increase or decrease the vapor flow rate, that will affect the pressure. In turn, it will affect the feed flow rate. We can control. Similarly, the steam flow rate also can be used to control indirectly temperature and pressure, so that we can control the feed flow rate. So, which one of these variable has to be used for feed flow rate? Similarly, for pressure also, FE, by adjusting FE, we can adjust pressure, or we can adjust feed flow rate, we can adjust pressure. Similarly, for temperature, we can adjust FE as well as steam flow rate. So, any one of these variables, manipulated variables, can be used to control any one of these 4 variables. That's why, which will be the best combination that we have to see. how many combinations are there means that is equal to 4 factorial. 4 factorial, 4 variables, 4 cross variables, and 4 manipulated variables. Therefore, 4 factorial equal to 24. There are 24 combinations are there, out of which we have to select one of these combination, 21 combination from 24. For that, what and all we have to consider? The first thing is we have to consider direct and fast. Which variable has direct effect? For example, if you consider the feed flow rate, if you consider the manipulated variable as feed flow rate, then it will be the direct and fast effect. And the smaller dead time. So, out of these 4 manipulated variable, which variable has small dead time for that particular process variable? That we have to consider. Second thing. Third one is minimal interaction. Minimal interaction. So, we have to see what is interaction that we have to see. Interaction means suppose you are having a process. The inputs are M1 and M2. Let us assume the outputs are Y1 and Y2. Outputs are Y1 and I2. If you change M1, Y1 also changes. Already we have seen all the 4 manipulated variables have impact on the 4 process variables. That's why Y2 also having a changes, small change. But if you see that M1 we are going to use control Y1, but it also affects Y2. This is called interaction. M1 having interaction on Y2. Similarly, if you adjust M2, Y2 also changes, Y2 also changes, Y1 also changes. This change in M2, because of change in M2, how much Y1 changes is called interaction. So this interaction must be minimum for a particular combination. That also we have to see. So we have to consider three effects. One is the manipulated variable should have a fast and direct effect on the process variable. The first point. Second one is it should have smaller dead time. M1 has smaller. If you use M1 to control PV1, it has small dead time. Suppose you are using M1 to control PV2 means higher dead time means we should use this. That way we have to consider. The third one is minimal interaction. We cannot avoid interaction, but interaction must be minimum. So minimal interaction. Like that, we have to select the combination. So these are all called qualitative analysis. Qualitative analysis. By doing the qualitative analysis, we have to select the variables. Already we have seen that there are 24 possible combinations. What are they? That we'll see now. So to control feed flow rate, we can use feed flow rate. So how many, if you keep that feed flow rate constant up to 6 ways, the remaining 3, if you put the permutation and combination, you will get 6. Feed flow rate is kept constant. The remaining 3, pressure can be controlled by liquid flow rate or vapor flow rate or steam flow rate. Similarly, temperature can be controlled by steam flow rate or vapor flow rate or steam flow rate. Like that, if you modify these 3 combinations, you will get 6 such combinations. Then, if you control feed flow rate by liquid flow rate, another 6 combinations. The remaining 3 will put a permutation and combination, you will get another 6. Then, if you control the feed flow rate by vapor flow rate, the remaining 3, if you put another 6 combination, you can put. Therefore, there are 24 possible combinations will be there. 24 possible combinations will be there, out of which we have to select only one. How to select that? The first thing is, if you want to control the temperature, means temperature has to be controlled. Temperature has to be controlled. Temperature has to be controlled. But all the four variables having, if you increase the feed flow rate, temperature will decrease. So if you decrease feed flow rate, temperature will increase. That's why feed flow rate have impact on temperature, but indirect effect. If you consider the steam flow rate, it has direct impact. Because if you increase the steam flow rate, temperature will increase. If you decrease the steam flow rate, temperature will decrease. That's why steam flow rate has the direct impact. Similarly, liquid flow rate, if you increase the liquid flow rate, temperature will increase. If you decrease the liquid flow rate, temperature will decrease. If you increase the liquid flow rate, temperature will, because the level decreases, that's why temperature will increase. If liquid flow rate, if you decrease, level will increase, that's why temperature will decrease. So you can use liquid flow rate, bottom product also, flow rate of bottom product can also be used to control the temperature. Vapor flow rate also can be used to control the temperature. If you increase the vapor flow rate, what will happen? If you increase the vapor flow rate, pressure inside will decrease. If pressure decreases, boiling point will decrease. That's why temperature will decrease. So by adjusting this vapor flow rate also, we can adjust the temperature. So, but anyhow, which has direct impact, steam flow rate. That's why we have to consider the steam flow rate as a manipulated variable for temperature. If you consider that way, which are all out of 24 combinations, this one has, first one has steam flow rate as a manipulated variable for temperature. Then third one is steam flow rate to control temperature. Seventh one is 1, 3, 7, then 9, then 14, then 18. That's all. So out of 24, 6 combinations. 6 combinations will give temperature control by steam flow rate. That's why out of the 6, we have to select only one. Now, if you consider feed flow rate, because feed flow rate has a direct impact on feed flow rate. So it is better to use feed flow rate to control feed flow rate. That's why if you consider that only 1 and 3 are there. 1 and 3 are using the feed flow rate as manipulated variable to control feed flow rate. So 1 and 3. Out of 1 and 3, which has to be selected? We have to consider the other 2. For pressure control, here liquid flow rate is used. Here, for pressure control, here vapor flow rate is used. If you consider that pressure, vapor flow rate will be better impact, because liquid flow rate has indirect effect. If you increase the liquid flow rate, level will decrease. Level will decrease. That's why pressure will decrease initially. It is indirect effect, not direct effect. But if you use to control pressure, if you use vapor top product flow rate, it has direct impact on that. That's why 3 has to be selected. If you consider for to control feed flow rate, we are using feed flow rate as manipulated variable. To control pressure, we are using vapor flow rate is used. To control temperature, steam flow rate is used. To control level, liquid flow rate. That's why liquid flow rate has direct impact on level. That's why it is better to use liquid flow rate. out of 24, this combination, that is the third combination, gives the better combination, best combination to control the 4 variables. This is called the qualitative analysis to find the manipulated variables. Qualitative analysis to find the manipulated variables. That's why we have to use this third combination to control these 4 variables. So this way we can find the loop configuration by analyzing qualitatively. This can also be done in quantitatively, that we will see later.